Hello students, welcome to today's session. Today we are going to start with chapter number 5, that is user defined methods. So methods and functions, they are same, okay. I'll be using the words interchangeably. Let us understand what are functions. When you are writing a program in Java, you can have thousands and thousands of lines of code in a single program. Now if those thousands of lines are written in a single function, you know that in a Java program there must be at least one class, and within the class there must be at least one function, and inside that function you will have your Java statements. So if you have thousands and thousands of lines in just that one single function, you will run into many problems, okay. For example, imagine you have got a book, okay. Let's talk about the computer applications book itself. Now imagine that the text is written line by line without any division of chapters, and within the chapters without any division of different topics, okay. So just line upon line upon line upon line, no division of any kind. So will it be easy to read and understand the book, or will it be difficult? I am sure most of you will agree that it will be difficult to read and understand the textbook. Similarly, if you write your entire program inside one function, it will be difficult to read and understand the code. So that is why functions are required to segregate your program into multiple functions, so that you will have the advantage of understanding the program easily, okay. Apart from that, if there is any error in the program, then it will be easy to identify and target a particular function which is responsible for the error. You don't have to go through the entire program, okay. Let's take the example of Campus Care. In the Campus Care app, you are required to input your username and password, and then only you are allowed to use the app. Now let's say you are able to use the app even without correct username and password, then that is an error, right? So the programmer needs to fix this, and that can be fixed by targeting only a few functions, or it may be a single function, or it can be one or two functions relating to logging the users inside the program, okay. So there is this word in programming called bug, okay. So whenever there is an error in the program, that is known as bug, and the process of solving the error is known as debugging. Okay, so functions help to make debugging easier. So we talked about the advantage. The first advantage was that functions improve the readability of the program, and number two, the advantage is that debugging becomes easier. So that is why functions are needed. Now let's talk about what are functions. Okay, so functions are collection of valid Java statements, okay, enclosed within a block. Okay, so let's say this is our block. Block is always represented by a pair of opening and curly braces. So inside this block you'll write your Java statements, okay, and this particular block will have some name. Okay, for example, let's call it display. So the name of this block is display, and it will also have the return type. Now whenever you want to execute all these instructions, you do not have to rewrite the entire set of instructions again and again. You just have to call the function by writing its name followed by parenthesis. So let's look at an example in BlueJ. So I've got a class called test here. Now I'm going to make a function named as display, and I will write a few lines of code here. Okay, so I've made a scanner object, and with the help of that scanner object I'm going to take a string input. I will ask the user to please enter your name. Okay, and then I will take the input with the help of sc.next line. So once I have the name, I will simply display a message welcome whatever the name is entered. Okay, so you can see that in this display function I have got 1 2 3 4 statements, 4 lines. Okay, so now whenever I want to take input from the user and display some message, I can simply call the display function. Okay, so let's look at an example. Let's try to use the display function by calling it in some other function. Okay, so I made a main function. In this main function I'll be calling the display function once. Okay, so let's compile it, and we have an error here. Okay, I've made this static, no problem. Just remove this static, compile. So let's compile the program and let's call the main function. So let's enter the name. Okay, let's give the name as Tom Harry. So you can see that my program is taking the input from the user, and then it's displaying a message, welcome Tom Harry. Okay, whatever the name is entered. Now let's say I want to do this 5 times. Okay, I want to execute all these lines 5 times. That means, and do I need to write these lines 5 times? Okay, 5 into 4, 20. Is it like that? Am I going to write it 20 lines? No, it's not like that. I am simply going to call the display function 5 times. That's it. So as you can see, I've called display function 1, 2, 3, 4, 5 times. Okay, so now the program will take a string input 5 times and display the welcome message. So let's compile and look at the output. Okay, so first I'm going to enter, let's say, ABC. Okay, so as you can see, it's showing welcome ABC. Then I'm going to enter another name, let's say DEF, is showing welcome DEF. Then I'm going to enter GHI, it's showing welcome GHI. Then JKL, it's showing welcome JKL, and then I'll enter MNO. So it's showing welcome MNO. So this process happened 5 times because I called the display function. 5 times here. So all these 4 lines were executed for 5 times. Okay. So you can see that functions make our life easier. Because it allows to call the functions just by the function name, and whatever is present inside the function body, that is executed. Okay, so we have seen what are functions and we have seen the need of functions. Now there are 2 different kinds of functions. Okay, one is system defined and the second one is user defined. System defined functions are those functions which are already defined in the programming language itself. Okay, so for example, when you use the system.out.println function, okay, you are using a system defined function. Okay, when you use math.pow, okay, so this is also a system defined function. we did not write the code for print line, we did not write the code for POW. Okay, we are able to use whatever code is written inside println. Okay, we are able to use that code just by writing the function name, that is println followed by parenthesis. Now imagine if this print line function was not there, you would have to write so many lines of code, okay, several lines of code just for displaying something on the screen. So will it be efficient or inefficient? So it will be very inefficient, it will be a waste of time, okay, if you have to write 100 lines just for displaying something on the screen. Instead, system defined functions are there to carry out the common tasks required frequently, okay, and those functions can be called as and when and as many times required. And user defined functions are those functions written by the programmer, by the user of the programming language, okay. For example, in this example we have created a display function, isn't it? We have created a display function here. So this display function has been created by me, okay, so we'll call it a user defined, we'll call it a user defined function, okay. Whereas this system.out.println, this will be called as system defined function, okay. But the process of calling a function is same for both the system defined as well as the user defined. If you notice here, when I am calling the display function, I am just writing the name of the function, which is display followed by parenthesis, okay. Similarly, when I call the println function, which is system defined, I just write the name of the function followed by parenthesis. Now parenthesis, inside the parenthesis it can be blank like here, okay, or it can have some data in it, okay. That we'll see later when we discuss about parameters of a function. Now let's understand a few words here, like function prototype, function body and function signature. So this line here, okay, this is known as the function prototype. This is known as the first line of the function is known as the function prototype, and the set of instructions which are enclosed within the curly brackets are known as the function body, okay. So in this example, which one is the function prototype and which one is the function body? This line here, void main, this is the function prototype, as it is the first line of this particular function, okay. And the instructions written within the curly brackets, okay, within the curly brackets, that is known as the function body. And what is function signature? The function signature is represented by the function name followed by the list of its parameters. In this example I don't have any parameters, but I do have a function name, so the signature in this case will be display. Okay, so the name of the function, okay, and the parameter list. These two comprise the function signature. We'll be looking at parameters later, don't worry about it. Okay, now we have to understand what is a calling function and what is a called function. Okay, so let's look at this example here. This function, the main function, is calling the display function, isn't it? How do we know that it's all these statements are function call statements? Because we have written a function name, isn't it? Display is a function name, and when we do not have any return type, we do not have any return type before the function name, that is known as a function call statement. Okay, so the function call statement also lies within some function. In this case it lies within void main, isn't it? So this void main will be known as the calling function, okay, whereas this function will be known as the called function. And let us also understand how the transfer of control happens. Okay, so when I compile this program and then I created an object for the test class and I called the main function. Focus here, I am calling the main function, okay, and main function in turn calls the display function. So when I chose to execute the main function, okay, the control came inside, it called the display function. Okay, so when the display function was called, the control will immediately transfer to the display function. Okay, and this main function will be paused until all the statements present inside the display function are executed. So now the control is in the display function. So first this line will execute, then this one, and like this all the statements will execute. When the last statement is executed, the control will automatically return back to the calling function on the same line. Okay, and if there is any more operation, if there is any more instruction in that same line, then that will be executed, else the next line will start its execution. So the next line is line number 19. Line number 19 is also a function call. So what will happen? the main function will be again put on pause, and the control will be transferred to the display function. Okay, so again all the statements will be executed. Okay, once that is done, the control will return back to the same line of the calling function. Okay, so this is how the control flows from the calling function to the called function, and from the called function back to the calling function. Now let's also understand what can we write in the function prototype line. Okay, how can we declare the function? So in the function prototype line, I can write I have to have an access specifier first. Okay, after the access specifier I need to write the static keyword. After the static keyword I must have the return type. After the return type I need to have the function name. Okay, the function name will be any valid identifier, and after the identifier we'll have a pair of opening and closing parenthesis. Okay, and then finally I can make the function body. Now the access specifier can be either public, it can be private, or it can be protected. And the access specifier, okay, access specifier and static, both of them are optional. Okay, that means even if you do not write, it's not a problem in the function prototype line. If you do not have access specifier and the static keyword, it's not a problem, but you must have the return type as well as the identifier, then followed by parenthesis. Okay, so the return type can be any valid primitive type as well as non-primitive type. Okay, but we'll focus on primitive types. So what are the primitive types? You can have byte as the return type, you can have short, char, float, double. Okay, so boolean, any primitive type can be written here. Okay, which will be called as the return type. If I make the return type as byte, the function will return a byte value. Okay, if I make the return type short, then the function will return a short type data. If I make the return type as boolean, the function will return a boolean type data. Okay, which will be either true or false. Then identifier is the function name. Now the order in which you write the return type and the identifier is important. Okay, you cannot write the identifier first and then return type later. No, you have to follow this rule that you have to write return type first and then the identifier. Now let's discuss the return type in detail. So let's remove whatever is written here. Okay, so let's say I'll make the return type of the function display as int. Okay, that means the display function, okay, the display function is capable of returning an integer data type. Okay, let's see how it can be done. So let's declare a few variables here. Okay, let's say int a assign 2, then int b assign 4, and then I will say return a plus b. Okay, and in the main function I will call the display function. I will call the display function by writing the name of the function followed by parenthesis. Okay, so let's compile it and then create the object, and I will call the main function. Okay, I will call the main function, which in turn will call the display function. So let's call the main function. Okay, so as you can see, there is no output right now because we are not displaying anything. First, let us understand what is the process that will happen here, and then we'll do something for showing the output. Okay. So I will call the main function, right, and main function in the first statement we have a function call statement. Okay, we are invoking the display function. We are invoking the display function from line number 15, okay, which is present inside the main function. So the control will transfer to the display function. Okay, so first line will be executed, which will assign 2 to a, then next line will execute, it will assign 4 to b, and then addition of a and b will happen, that is 2 plus 4, which is 6. Now this value 6 will be returned to the same line from where the function was called. So now you can, let me ask you a question. What is 2 plus 4? You'll say 6. What is 5 into 2 plus 1? So this will be 11. What is 5 minus 4 minus 1? So this will be 0, right? What is 5 minus 2 plus 1? Or let's make it 7. Okay, so this will be 5 minus 2 is 3, 3 plus 7 is 10. Okay, so all these expressions, all these different expressions, what do they have in common? If you notice, that every expression is resulting in a single value. Okay, every expression is resulting in a single value. So that is the speciality of expressions. Okay, they will always result in a single value. So this function call statement here, okay, this function call statement here can be also called as an expression. Okay, and what is the speciality of an expression? That it results in a single value. Okay, so what will be the result of this expression, this function call expression? What will be the result? The result was provided by this statement. Okay, the result was 6. Okay, so the result of display function call is 6. Okay, now I can do anything with this 6. Okay, I can either pass this 6 to system.out.println. Okay, I can pass this 6 value to system.out.println, right? Okay, so that 6 value will be passed to println and println will display 6 on the screen. So let's look at the output for this. So as you can see, output of this program is 6 and the output is provided by this line here. So that's one way of receiving the data. Okay, that's one way of receiving the data. Now instead of displaying instead of passing the value to println, I can store it in a variable also, right? Let's say I'll store it in num. Okay, so in this case, whatever value was received here, that is 6, will be stored in num, and that value can be used down the line. Okay, anywhere in the future. So for example, I can do some calculation with num here. Okay, I can do like this, system.println, I will just say hello. Okay, anything I can do. Okay, and let's say now I need, after this statement, I need to use the value of num, so I can use it. Int z is equal to num into 2, and then if say I want to print the value of z. Okay, if I compile it, let's check the output. So as you can see, six got returned here and it got stored in num. Okay, then on the next line I am printing hello. Okay, so that got printed here, hello, and then in the next line I am using the value of num which was received here. Okay, so num was 6 and 6 into 2 is 12. 12 got stored in z, and that z is finally printed as 12. Okay, so the benefit of storing the returned value in a variable is that it can be used anywhere later in the program. Okay, now whether you want to store it or you want to display it, that is completely dependent upon the requirement. Okay, it's not, there is not any hard and fast rule that you have to use a println statement or you have to store. It's completely dependent upon the requirement. So So the return type was int here. That is why I was able to write a return statement with an integer value. Can I return a boolean value here? Can I do this? So you can see that this is giving me an error, incompatible types. Okay, so the return type is int, but I am trying to return a boolean value. That is why it is showing me an error. Okay, the return type should always match with the value that is being returned here. Similarly, can I return a double value, let's say 5.3d? Can I do this? This also cannot be done. Okay, incompatible types. Okay, can I return a character here, let's say f? Yes, that can be done. Why? Because character is smaller than int, right? Character is smaller than int, so it can be done. Similarly, byte and short type also can be returned. Okay, because of automatic typecasting or implicit typecasting. Okay, you already know that when you try to assign a smaller value into a larger variable, okay, typecasting happens. Okay, and specifically implicit typecasting happens. So your smaller data type is converted into the larger data type. Okay, for example, if you try to store an int value into a double variable, the int value will be automatically promoted to a double value. Okay, that is known as widening conversion. Okay, and the process is known as implicit typecasting. Okay, so that is why I can return a smaller value than whatever is mentioned here, as well as the type that is mentioned. Okay, let's just look at another example. If I write double here, okay, if I write double, I can return integer value. Okay, so this time also we have an error, but the error is not occurring in this line. Earlier the error was occurring in line number 10. Now there is no error in line number 10. Okay, although the return type is double and the value that I am returning is integer, it will not result in an error because integer will be promoted to a double value, and that double value will be what? It will be 232.0, isn't it? So the value which is being returned here, okay, that is what? 232.0, which is a double value, and I am trying to assign a double value into a variable which is of integer type. So what am I trying to do? I am trying to assign a larger value into a smaller variable. That is why it is showing me the error. Okay, so I can fix this by changing the type of num to double. Okay, so I can change the type of num to double. Okay, so this is one way I can handle it. Let's see the output first. So as you can see, the output is, the value of num is 232.0. okay, here 232 was returned, okay, but this got converted into a double, and that double value got stored in num. Okay, when I display num, it will be 232.0 and not 232. okay, it's not 232. So I changed from int to double, right? But if I want, I can explicitly typecast this to an integer. Now the double value, okay, so although 232.0 was returned, this explicit typecasting will convert this 232.0 to 232. okay, so the output this time for num will not be 232.0, it will be 232. Let's have a look. So as you can see, the output is not 232.0, it is 232. okay, so I hope you have understood that the return type and the return value should match, or the return value should be smaller than the return type. So that's it for today's video. In the next video we'll discuss function parameters. okay, so thank you for now. I'll see you in the next video.